Okay, so welcome to this video. Today we're going to be looking at powers, squares, and roots. Now, as usual, we've got our learning goal here, and that is that students will understand index notation and the relationship between perfect squares and square roots. So this is a new learning goal for us so far this year. Okay, and what you're going to want to be able to do after this video and the related exercises is expand and evaluate a number that is in index form, simplify an expression using index form, recall the set of perfect squares up to from 1 squared up to 12 squared, and evaluate the square roots of perfect square numbers. Okay. Good, so we've got a good question of why bother with another way of writing numbers when really numbers with indices are just the same as another normal number. Like you might already know that the number 3 to the power of 2 is the same thing as 9. So if we can write 9, why bother having this 3 squared thing? Well, the reason is because have you thought ever about how much the mass of the Earth is? And you might think, oh, is it a billion kilograms? Well, it's actually a billion, almost a billion kilograms. And so that's a lot of zeros to worry about. So we write that we can say the mass of the Earth is about 6 times 10 to the power of 24 kilograms. Okay, so it just makes it so much easier. Otherwise, it would be a 6, or we could write 6 0 0 0 0 0 0 0 0 0 0 0 24 zeros. That's a lot of zeros. Crazy. So that's why we sort of like want this index way of writing things. So it's just way more easy for us. Okay, right. So let's have a look at a couple of our key ideas. Is that repeated multiplication can be simplified using powers, okay? So if we've got maybe, let's say 6 times 6 times 6 times 6 equals, what we do is if we've got the repeated multiplication and they're all the same base, okay? We'll see what that sort of means in a sec. We write 6 here because that's the number that's being multiplied. And how many times is it being multiplied? Let's see, 1, 2, 3, 4. So 6 to the power of 4. Okay, so this part down here, this is called the base. And this thing up here is called sort of the index or the power or the exponent. There's heaps of names for it, which is a little bit frustrating, but you just sort of got to get used to it. Okay, right. Now, in the same way as we can simplify repeated multiplication, we can also get a number that's in index form and expand it. So if we have 5 to the power of 7, that means that the base number here is multiplied against itself 7 times. That's what the 7 up here means. Okay, so that'll be 5 times 5 times 5 times 5, that's 4 of them, times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7. 7 of them all together. So that's why we got 5 to the power of 7. Now, here's a big one for you to be careful of. Caution! 2 to the power of 3. So 2 to the power of 3 is not the same as 2 times 3. It doesn't mean that you just multiply these two numbers up here. Okay, 2 to the power of 3 actually is a 2 times a 2 times a 2. Okay, because 2 times 3 is 6, whereas 2 times 2 is 4 times 2 again is 8. So you can see they're not even remotely the same number. Okay, right. Now remember, in our hierarchy of operations, powers are second. So if you have something like 4 times maybe 3 squared, you have to do this part here first, the 3 squared. Okay, and so you would have 4 times 3 squared is 9, and 4 times 9 is 36. Okay, so that's, remember sort of where they are in the hierarchy of operations from the last video. Now, perfect squares are a special Now they're the result of an integer being multiplied by itself. So something like 7 times 7 being 7 squared, that's a perfect square. So the perfect square is 49. Okay, and the reason why that is if we get, a block, like we're talking about areas, that's so 7 long and we make it 7 high, you can see that it will make a square of 49 blocks. You can sort of see that's going to be the case. Alright, so that's why we call them square numbers and perfect squares. Okay? Now, here's this other operation you need to be familiar with. So we've got this thing here called a square root operation. Okay? And it looks like this thing here. I'll write it a little bit bigger for you. So we got, that's the square root operator. We put 16 inside it. Okay, sometimes you might see a little tag along the end there, and that sort of helps group things in, because sometimes there's even more things inside a square root operator. Okay, so you need to be sort of careful to see how that's going. Now, the square root operation, for instance with square root 16, asks what number, when multiplied by itself, gives 16. Okay, now, I know, and you might know, is that the answer to this is 4, because 4 times 4 is 16. So what number, when multiplied by itself like this, gives 16? Well, it's 4. Okay? Now, squaring and square rooting are the opposite operations. So if I had the number 7 and I squared it and then took the square root of 7 squared, that would be 7. Okay? They kind of undo each other. Kind of like multiplication and division are opposite operations. Okay? And the same way, if I get the square root of 7 and then I square that, that would also be 7. Okay, so they're the opposites of each other. They undo each other as operations. Okay, I'm just going to show you a couple of quick examples of stuff that you might need to have a go at in your text and in the exam and things. So, firstly, write 5 times 5 times 5 times 2 times 2 times 2 using index notation. So when you do this, you say, right, what's the first number that I come to? It's a 5. So I write 5, and how many of them are there in this expression? There's 1, 2, 3. So 5 to the power of 3 times. My next base that I come to is 2, and it's multiplied against itself 3 times. So 5 times 5 times 5, there's our 5 cubed. 2 times 2 times 2, there's our 2 cubed. Done. Okay? Right. Here's another one something you might need to do. Evaluate 10 squared plus 3 squared minus 4 cubed. So remember, all of our squareds need to be done, all our powers need to be done first. So let's just rewrite this for ourselves. So that's the same thing as 10 times 10 plus 3 times 3 minus 4 times 4 times 4. Okay? So 10 times 10 is 100. Plus 3 times 3 is 9. Remember, you do your multiplication all at the same time, from left to right. Minus 4 times 4 is 16, times 4 is 64. And so 100 plus 9 is 109. Well, so 100 minus 64 is 36. Plus 9 is 45. 45. Okay? So that's how you would evaluate that. And lastly, something you might be asked to do is, like this one here, evaluate the square root of 49. So remember, that's asking us what number, when multiplied by itself, gives 49. And if you know your squares and square roots well, you will know that that is 7. Now you want to know everything from 1 squared through to 12 squared. Okay, so we're going to look at that in class, maybe do some exercises. There's some stuff on Hot Maths for you. So I hope you enjoyed the video, and make sure you have a look at the exercise list and see what you need to do in class. Okay, thank you.